this video I'm going to be working out an individual integral. I'm going to take a look at the integral of e to the x sine x dx. Now this is going to involve integration by parts. However, I'm going to do an integration by parts shortcut method. Alright, this video is not really to teach that shortcut method. I've got several other videos on my channel that actually go through and explain how to do the shortcut. This is just after you know that shortcut, then this is just showing you how another example of this would be working out. Alright, so if I'm going to do this shortcut method, I need a derivative column and an integral column. So I'm going to choose those two columns, get that set up. Okay, so I'm going to choose my derivative and integral just like I would normally for integration by parts. So therefore I'm going to pick my derivative to be my e to the x. I'm going to pick the integral to be the sine x. Alright, so I will go down my derivative column. When I take the derivative of e to the x, I get an e to the x. Alright, so this isn't going to help me much because every time I'm just going to keep getting e to the x. Alright, so that kind of tells me that I'm going to be looking for a matching term here that's going to match what I have in my original integral. So then when I take the integral of sine x, I'm going to get a minus cosine x. Alright, at this point, this times this does not match this. I don't have a matching term yet, so I'm going to go again. The derivative of e to the x is e to the x. If I take the integral of a negative cosine x, I'm going to get a negative sine x. Alright, now at this point I'm going to stop and I'm going to look. I've got an e to the x times sine x times the negative sine x, alright, which is the exact same thing I have in my original integral, which is an e to the x times the sine x. So that's telling me at this point I need to stop because I have matching terms. Okay, so in other words, the original integral and this term right here are matching, so that's how I know to stop. Alright, I talk about a variety of other cues as to how far you have to go down in this shortcut in the video where I actually explain the process. Alright, now the rest of this I automatically start with a plus sign and a minus sign and a plus sign alternating the rest of the way down. I multiply on the angles and anything left over I integrate going back the other way. Okay, so there is basically the shortcut done here. So I'm going to rewrite this integral and make an equation to be able to solve this here. So I'm going to have my original integral, the integral of e to the x sine x dx. That's going to be equal to what I get when I multiply on the angle here, so a negative e to the x cosine x. Multiplying on this angle, a negative times a negative is going to be a positive, so a plus e to the x sine x. Alright, and then integrating on going backwards here, then it will be minus the integral of an e to the x sine x dx. Alright, now I have an equation here, so I can manipulate terms just like I would in any ordinary equation here. Alright, there's a little imaginary 1 in front of both of those integrals. Alright, so basically this says minus this integral, so I can add it to both sides. Well, if I add this integral to the right hand side, then basically it's going to go away. If I add it over here, add the integral of e to the x sine x dx, well basically now I have two of them over here on this side. So I'm going to write 2 times the integral of e to the x sine x dx, and that is equal to, at this point I think I'm going to rearrange those just because that's a leading negative right there. So e to the x sine x minus e to the x cosine x. I've got a 2 out in front. I'm trying to solve this integral, so now I can divide by 2, divide by 2, and divide by 2. 2's will cross off here, so then I'm going to be equal to, and it depends on how much you want to factor out, if you want to factor anything out or if you just want to leave it in that form, but basically e to the x sine x over 2 minus e to the x cosine x all over 2, and then don't forget the plus c because you have now integrated this. Alright, this shortcut method, once you learn it and you learn when to stop and what you're looking for and how to pick your derivative and integral column, that shortcut method really does work. And like I said, if you want detailed instructions on this shortcut method, I've got a video on my channel that definitely goes through like 4 or 5 good examples of different scenarios that you're going to hit every time you try to use this shortcut method. So definitely thanks for watching. If you're enjoying the videos, please subscribe to the channel and share with your friends. Thanks.